So space physics exercise, page 9 onwards we will do. This question is about the planets in the solar system. The planets in the solar system have different sizes and masses. The bar chart shows the gravitational field strength of each planet compared to Earth. Like it's a comparison to Earth. The ratio is there. Which of these statement is correct? Which of these statement is correct? You can annotate on the screen. So the first statement, 1 kilogram weigh more on a Venus than in Neptune. So 1 kilogram weigh more on Venus than Neptune. That is not correct. 1 kilogram weigh more on Mercury than Saturn. Mercury and Saturn, that's also not correct because Saturn is having a stronger gravity. 1 kilogram weigh more on Mars than on Jupiter. So it's having a weaker, so this will not. So B is the right answer. On Earth, the gravitational field strength is 10. Which of the values is a gravitational field strength on the Mars? You can use this ratio. Like if on Earth this is compared to the Earth, the gravitational fields and the ratios are given. So this is 0.4, like 0.4. So the ratio between, as I mentioned, the bar chart shows a gravitational field and compared to that of Earth. So gravitational field strength of the Mars divided by gravitational field strength of the Earth, the ratio is 0.4. So which is a value for the gravitational field strength on the Mars? So it will be 4 Newton per kilogram. If we take because they mentioned take gravity as 10. So if we take this gravity of the Earth as 10, so gravitational field strength on the Mars divided by 10 is 0.4. 10 is multiplied there, so that will be equals to 4. Demos is a natural satellite of the Mars and it has an orbital time period of 1820 minutes with an orbital speed of 1350 meter per second. Calculate the orbital radius. So whenever object move in a circular path, as we know, speed is distance over time. But in a circular path, what is the distance? It will be 2 pi r and divided by time, t. So if we need the orbital radius, like r is our subject, so it will be speed multiplied by time divided by 2 pi. That will be r. What about the speed? Speed is 1350. The time, because speed is in meter per second, so time should be in second. So it will be 1820 times 60. So we convert into seconds. And then this is divided by 3.14. This will give us a value for r. What is the radius? That will be in meters. So 2.3 exponent 7 and then meter. If you can divide by 1000 to convert into meters, into kilometer, but if it's not, then you will get answer in meters. The diagram shows this moon, which is orbiting the Mars, which arrow indicates the direction of the gravitational force that the Mars exert on this moon. A, B, C, or D. So it is to pull, that's right, the gravitational field strength directed. And what is the effect of this gravitational field strength? Whenever object is experienced, like the motion is in this direction and motion and the force are perpendicular, the object will move in a circular or a curved path. So A is the right answer. The moon orbits the earth. State the difference between orbit of the moon and orbit of the planets. How they're different from each other. Moon orbit is the moon orbit the planet and planet orbit the star. Okay. And another difference. The difference between the planet orbit of a moon and usually the moon orbits are circular and the planet's orbits are elliptical. You can also refer a moon orbit. The orbital length is shorter for moon as compared to that of a planet. That's right. You can mention that. The radius of the moon orbit is um, 385,000 kilometer and it takes 27 days to complete one orbit. Calculate the orbital speed. So we can find orbital speed in either kilometer per hour. So days are there. We have orbital speed, a suitable unit. So we have the formula, the orbit, like we have this formula, speed is distance divided by time. So whenever object move in a circular path, so distance is 2 pi r and the time is t. So it will be 2 into 3.14 into radius of the orbit, 385,000 kilometers. And the time it is taking 27 days, but we convert into R. So we multiply by first 27 days are there. So we multiply by 24 to convert into hours. As one day is having 24 hours. And then if it is minutes, we'll multiply again by 60 and second again by. So that's in kilometer per hour. Kilometer per day, you can use that because any unit as give a suitable unit. So it can be kilometer per day. That's fine. It can be kilometer per second. If you want a kilometer per day, just this, you don't have to convert in that case. No need to multiply by 24, just divide by 27. Then how many kilometers in one day the moon cover? Or, according to its orbital speed? 90,000 kilometer per day. Okay. So about 90,000 kilometer per day the moon covers. The table shows some data about the planets in our solar system. You're not supposed to learn this table. They will ask you the question related to the table, not you don't have to memorize anything from the table. You can see diameters are there in kilometer, and the distance from the sun in exponent 6 is given. The time of the orbit compared to Earth, this because time is not absolute. Like for us, 24 hours duration will not be same as 24 hour on other planet. That's why it is written Earth days. Use the data from a table, give the answer this question. Which planet has about the same diameter as Earth? Which planet has the same diameter as Earth? Venus. So Venus is having the same diameter as Earth. The next one, the Jupiter has the largest gravitational field strength. Look, remember one thing, gravity depends, suggests a reason for that. Why Jupiter is having the largest gravitational field strength? What is, so which column? Effect, distance from sun, diameter, time period, mass. Which column? Mass. Mass is because greater mass means stronger gravitational force. So you will just mention because Jupiter is having a greater mass, the greatest mass. Size is not the factor. Maybe size and mass both refer because if it is a large size and it has more particle, mass is the one which decide the gravity rather than the size. Because for example, if I say a room is there, a large room which is filled with a gas. So the gravitational force of a gas is very weak because the number of the particles per unit volume. So it's you can say density or you can compare the mass. State the equation linking the density, mass, and volume. How we can relate the density, mass, and volume? So density, mass by volume. Calculate the density of a Neptune in kilogram per kilometer cube. Yeah, that's right. Density is mass over volume. So we need the density of Neptune because we consider them as a sphere, the gas giants. So we want kilometer per kilogram per kilometer cube. So we need kilogram, our unit kilogram per kilometer cube. So we have the mass, the Neptune, the mass is given. So we have 100 into 10 power 24. But what about the volume? Volume of a sphere, it's 4 by 3 pi r cube. And diameter is given. Diameter of the planet is given. So what about the radius? So radius will be half of the diameter. If 50,000 is our diameter, so radius will be 25,000. So it will be pi 25,000 cube. So this will be 4 multiplied by pi multiplied by, you can separately get the volume like 4 into pi into 25,000 cube divided by 3. This will give us the volume and then substitute the volume here. You will get the density in kilogram per kilometer cube. What is the volume of the Neptune? For 25,000 cube multiplied by 3.14 multiplied by 4. So it is 6.5 exponent 13. Okay. So 6.5 into 10 to the power 13 kilometer cube. So if we substitute 6.5 into 10 to the power 13 kilometer, this was in kilometer cube and this is in kilogram. So 100 exponent 24 because 100 exponent 24 divided by 6.5 into 10 to the power 13. What's the final answer? It is exponent 10. Okay. Check. Can I have calculator? Or you check 4 into. So we have 4 into 3.14 times 25,000. I wrote 2,500, I guess. Yeah, that's why this is 25,000. 25,000 cube. And then this is divided by 3. So it will be 6.54 exponent. 13 will be there. Because it is 25,000 cube. I wrote 2,500. That's why it was coming. Then it will be 100,000. 100 exponent 24 divided by 6.5 exponent 13. That will be 1.53 or 1.54, you can say. So this will be 1.54 into 10 to the power 12 kilogram per kilometer cube. So 1.5, we have to divide. No, because if you see the power, this is 24 and this is 13. So obviously, when we are dividing the positive powers, it will be like 10 power 24 minus 13 will be there. So there should be a reduction in the power. It cannot increase. So it will be 1.54 exponent 12 kilogram per kilometer cube. If the negative was there, like example 10 power 24 divided by 10 power minus 13, then when it will move in numerator, it will be 10 power 24 minus minus plus, it will be 30. In that case, it will be added. But because both are positive powers, so when we divide them, here, thank you. When we divide them, it should be subtracted. The orbital speed of the Earth in kilometer per second. How many kilometers Earth cover in 1 second? So If we need orbital speed of the Earth, the orbital speed is 2 pi r divided by t. So it will be 2 into 3.14 into radius of Earth, like this from the sun to Earth, how much is the distance? That is given 150. This is also called one astronomical unit, one exponent, 115 to 10 power 6 kilometer is there. So this will be 3.14 into 150 into 10 power 6 divided by the time Earth take. What is the time interval I should take? So because we want orbital speed, so the how much time Earth takes, it's written orbital the 365 days, but we need in seconds. So 365 multiplied by 24 to convert into hours, multiplied by 60 to convert into minutes, multiplied by 60 to convert into second. What's the final answer for the orbital speed of the Earth? 30 kilometer per second. That's right. So Earth actually travel 30 kilometers in 1 second. It is like about 29.9, which is rounded off to 30. A student says that the smaller the planet, the shorter its time, it's a period of orbit. Use the data from table, evaluate this statement. Smaller planets, shorter its orbital time. If the size of a planet is small, so if you see the size of the planet, like according to that, the Mars is there, which is smaller than the Earth. So you can see but the Mars is taking longer time than Earth. So size of the planet is not the factor which affect the time period. It's the distance from the orbital distance, that is what affect orbital distance and the speed. So evaluate the student statement. So for 3 marks are there. First thing, and use the data from the table you will evaluate. Like you will say the student statement does not match the result and or the table, the values in the table, and then you will list the Earth and the Mars. Like you can mention Earth is larger in size as compared to that in Mars, but Earth is taking a shorter time and Mars is taking longer time. So the student statement is not supporting the data, or the data does not support the student statements. Which list give the astronomical objects in order of starting with the largest? You can use screen annotation, which is the largest and which is the smallest. Which object is largest in size and which is the smallest? So galaxy, solar system, sun, and planet. Earth and Mars are the planets in our solar system. State two ways in which orbit of the Earth and Mars are similar. Two ways how Earth and Mars are similar in the orbit. No, not the question is about orbit, not similarity between Earth and Mars. So if you say they are rocky, then it is not acceptable. They are both or elliptical, that's right. Elliptical or even circular is acceptable, but better learn that the orbits are elliptical. Both are elliptical and both are orbiting the sun, or you can say star. But you cannot say rocky because that is about the similarity in their surface. One way orbit of the Earth and Mars are different. How the orbital orbits are different from each other. The time is different, or the orbital length of the orbit is also different. Length of the orbit is different, or the time or the distance, yeah, longer. So Earth or Mars orbit is longer than Earth, that you can mention. This a moon that orbits the planet Mars. The radius is given 23,500 kilometer, and the time period is also given. Orbital speed. So it will be 2 pi r divided by t. So 2 into 3.14 into radius, 23,500 divided by 1.26. So 1.2 into 10 power 5 kilometer per day. Yeah, so you can 1, 2, 3, 4, 5. 1.17 or 1.2 exponent 5. When you have a very large or a very small answer, write in exponents, scientific notation. Then we have Euclidus is a moon that orbits the planet Saturn, and it has a similar orbital period, but its orbital speed is 10 times greater. Suggest how this is possible. Like one moon was orbiting the Mars in the previous one, another one is orbiting the Saturn, and they have the similar orbital period. Like time is same. So, like example, this is representing the Deimos, and here this is representing Enceladus, which is orbiting the Saturn. Both are taking a same time interval. Like it is a similar, but its orbital speed is 10 times larger. So what might, because the orbital side is larger, like that's right, because we have the formula speed is distance over time. So if the time is constant, so speed and distance are directly proportional. So because they have the same orbital time, so it means for a time to be constant, if a speed is increasing, if the speed is increasing, so distance from the center is also increasing. So you'll mention Enceladus having a greater distance from the planet, or a or the orbital size is larger. As a result, it is moving much faster or a higher speed, so which makes the time constant. Like they take the same time. Say if this example, if this was taking say 20 hours, this is also taking 20 hours. But how both are taking the same time, even though their orbits are different, because this is moving faster than this one. Is it clear? This one, RD? So these are the questions from exercise space physics. Any question or doubt related to the session?